So the next presentation will be about why agents don't ship, closing the production gap for real business impact. Our presenter is Javier Poveda-Panter, specialist, solutions architect, Gen AI, and machine learning at Databricks. We've all seen too many impressive demos and too little real-world impact in day-to-day business. Most agentic demos never make it to production. But why? Drawing on daily work across this maturity curve, this talk breaks down the most important success factors. Waiting another 1 minute for the audience, and we can start. Okay. Javier, may we proceed? Yeah, I think the audience is ready. So Javier, the floor is yours. All the best.
Thank you. All right. Agents. Agents. I want to start by asking you, who of you had at least one moment in the past months where they got kind of sick hearing about agents all the time? Because, yeah? Okay, me too, I know. And I think one of the major reasons is we've seen all, a lot of impressive demos and prototypes, but very few of them make it actually to production where they can provide real business impact. And that's why today I want to talk about why agents don't ship and how you can close the production gap for real business impact. My name is Javier Poveda-Panter. I'm a specialist solutions architect for AI/ML at Databricks. And in the last 7 years, I worked for Databricks and AWS. And to summarize it in one sentence, I build scalable AI systems with customers. So let's start. Let's first agree on what an agent is, right? It's quite an overloaded term. When I go to customers, I sometimes have the feeling that everyone has their own, truth about what an agent is. So that doesn't really help us to build standards around how to deploy them, how to get them to production. So an agent is an LLM system where the LLM takes an active decision on which steps to take to solve a problem, right? It's not a hard-coded sequence of steps like in a RAG. In an agent, the LLM has agency, yes. So, for example, you have a customer that asks, can you please help me return my last order? It goes to the customer support agent, and then it can reason its way through the problem to the answer. So it's going to start by thinking about what to do. Then it's going to say, okay, I'm going to look up your last order, and I'm going to look at our policy documents to see whether you are eligible for a return. Then I'm going to think about what to do again. I'm going to start a return process, think about what to do again. I figure out I'm actually done. I go back to my customer and I say, done, here's your shipping label, the return process is started. So what are the most common agent design patterns that we see, out in the wild today? The most simple one, and also the most common one nowadays, is, an agent with documents, so unstructured retrieval, also called an agent RAG. Then increasing in complexity, we have agents with tables, right, text to SQL. Even a bit more complex, agent with multiple tools and data sources. Think a combination of the first tool plus maybe a web search tool or a tool that can run Python code. And then an agent that orchestrates other agents, also called an agent of agents, a multi-agent orchestrator. All right, so now let's look at the typical customer progression that we see with customers when they build agent systems. And this is going to look familiar if you ever looked at, at the progression in classic ML as well. So they start with experimenting to understand the technology. Then they prototype, they work on their first use case, they want to see whether they can prove value. Then they deploy it to production if they're successful, they monitor the solution, and if that is successful, they scale to having multiple agents in production. What we see is that most of the customers, they reach this second stage prototyping very quickly, because most of the tools out there today, they're designed to get you to stage 2 quickly, but then they don't really take you much further. And what we often see is, customers, they start prototyping on a use case without even having the intention of taking it to production, okay? They just want to see whether it works. But then it works, then they present it internally, maybe the CEO sees it, they say, okay, I love it, I want it in production as soon as possible. And that's when the scramble begins, and you have to somehow try and take what you have built, make it production ready, and get it running. And that's when, this gap between prototyping and deployment looks a bit more like a valley. Okay, so let's say you succeed, you get it to production, and then that's where a lot of new ideas come into play, right? Different domains, they come to you, they have also their ideas of agents that they want to build, and it quickly becomes obvious that the team that has built the first agent and brought it to production, they cannot scale to the extent where they can handle all of the additional ideas. So what can we do about it? Maybe this looks familiar, right? The MLOps lifecycle. Remember, MLOps 2019, 2010, 20 was a super hot topic because everybody knew how to train a model, but nobody knew how to get them to production. Today, we have a similar problem with agents. So to quickly recap, the process starts with data collections, then you clean your data, you create your features based on which you do model training in the framework of your choice. Then you evaluate with your validation and test set. If you hit a certain benchmark, you deploy it to production. And then once you are in production, you're going to gather more production telemetry that's going to help you to further improve the model. And the cycle repeats itself, right? It's a cycle with multiple steps where you need a different set of tools in each step, and multiple personas are involved. So what's changing when we move to the world of Gen AI and agents? So instead of data scientists, we have usually data scientists working together with software engineers. And they don't just train models, they build Gen AI applications. Why, right? Where the model, it's a part of it, but also around it you have tool calling, you have vector search, you have business logic. So it's not just an AI application, it's a complete software product. Evaluation also differs, right? Because the output is free-form and nuanced. That means in a single query, there can be 1,000 things that are correct or incorrect. So you need expert feedback and LLM judges to kind of make sense of that. And then deployment, it also differs. Because when you have like this multi-step agent, you need observability into each of the nodes. And again, because the output is free-formed, you need some kind of guardrail to make sure that you're not leaking sensitive information or providing harmful content. All in all, it still remains a cycle, and sorry. Yeah, all in all, it still remains a cycle. We have multiple personas involved. Okay, so what you can see is that AI tracing, it kind of plays a central role, right? It's very important in many of the steps, and that's because it's kind of the cornerstone in providing evaluation and quality in your Gen AI apps. And that's why I now want to dive a little bit deeper into tracing before coming to the evaluation part, because that's usually the two things that customers struggle with most. Okay, so tracing, right? What is tracing? Tracing is as central to building quality Gen AI apps than training and test sets are in classic ML, okay? But what are they? they're not just inputs and outputs to each query, but they also show you the inputs and outputs of each of the steps that the agent takes to create the answer. So that takes you away from guessing to knowing what's going on. In this case, we have a kind of a RAG application, and one of the steps is a vector store retriever, and it allows you to zoom in and understand what is exactly the text that went into the vector store retriever and what are the documents that it provided you back, right? Without knowing this, you can only guess what the problems are. And with this, you can start to understand the quality of each of the single steps and how they contribute to the quality of your overall agent solution. Now, I want to go over this GenAI app lifecycle again and highlight to you how you're going to use traces and what they provide to you in each of the steps. So when you're in development, you need to debug quickly, right? And you need to understand what's going on 10 layers down the stack, and this is going to help you to improve your quality quicker, and you're going to get to production faster. When you're in production, you cannot just rely on user feedback to provide you with feedback whether you're performing well or not, because there might be nuances or even big problems that you're not going to catch if you're just relying on the users telling you what's going on. That's why I need to collect those production traces, those in-depth logs, and run LLM judges on top of it to always know how your application is performing live. Then, once you hit production, you're far from done, right? You still need to improve because your first, second, even third, fourth version, they're usually far from perfect. So what that means, you need to continue collecting those traces. You need to supplement them with expert feedback, right? With ground truth labels. And then once you have the traces and the ground truth labels, you can build evaluation set, which is then going to allow you to do automatic evaluation of your different agent versions, which is then going to help you to improve the quality over time, okay? And then ultimately, the cycle repeats itself, and you do development, you evaluate, you promote to production, and traces remain a central part in each of the steps. So now that we understand the importance of traces and how they work, how do we actually use them for evaluation, right? In classic software, the inputs and outputs, they're usually much more fixed, okay? And the question is, how do we use those learnings, or how do we translate that to a world where we have to evaluate freeform inputs and outputs? Oh, sorry. So in classic software, we write and run code locally, we do unit tests, we do QA testing, and then we have production telemetry once we're live. At least for the first step, what we can do in GenAI is we can do prompt engineering and vibe checking, right? You give it a prompt, it kind of answers reasonably, okay, it gets you, somewhere along the way. But in order to have an equivalent for unit tests and QA testing, you need something more, right? And that's where you get into evaluation and expert feedback. And then when you're in production, you're going to have that production telemetry, but it's going to be very complicated, very complex, so you need automatic LLM judges on top of it to distill the quality information for you. But like you're wondering, what are those evals? What are those scorers that we can use to automatically get information on the production quality? And the key term is LLM as a judge, right? You use LLMs to judge the quality of the generation of another LLM. That might sound odd, right? Maybe you're asking, wouldn't the LLM that is judging the quality just make the same mistakes or might make the same mistakes that the LLM did when it originally created the content? And the answer is no, right? Because it's way easier to judge the quality of a generation than to produce the generation in the first place, right? I can tell you whether a painting is beautiful or ugly. That doesn't mean that I can paint it. I can review a text with a lot less effort and time invest than it takes me to generate the text, to write the text in the first place. And the same goes for LLMs, okay? But also, we cannot just evaluate the quality of a generation all in one sweep. We have to kind of slice and dice it. Because imagine you can have an answer from an agent that is completely factually correct, but the tone is unprofessional, right? We need to know those nuances in order to improve that. So what we really need is a multi-dimensional analysis. And now I want to show you some of those dimensions that are usually useful when you evaluate agents. For some of them, you need ground truth labels. For some of them, you don't. Some of them that don't need ground truth labels are, for example, relevance to query, right? Does the app response actually directly address the user's input, okay? Are you answering my question, or are you like a politician in a talk show where I ask you something and you talk about something completely different? We don't want that. Safety. Does the app's response avoid harmful or toxic content? Retrieval groundedness. Is the app's response grounded in the retrieved information? Retrieval relevance. Are the retrieved documents actually relevant to the user's input? How well is my vector search or my text-to-SQL engine, how well is it working? And then if you have ground truth, you can judge, correctness based on the ground truth label that you have, and retrieval sufficiency. And then finally, you want to work in an environment that lets you easily analyze how you're doing across all those dimensions, across your different versions of your agent, and across the different questions in your evaluation data set. Okay, so you want to have a nice overview where you can see, okay, this is my evaluation data set with the question and the response that the agent produced. Which version of the agent am I evaluating? And then how is it doing for each of the questions in the evaluation data set across all the different dimensions that we defined. Okay, once I have that, I can be confident going to production. And then once I am in production, I can sample the traces from my production telemetry, and I can run the same scorers that I used in development on the production traces, and I always have a good understanding of how my agent is doing in production. Okay, now we're confident going to production. Then, how do we scale? How do we scale this to the next level? Well, let's talk about the data mesh. Remember the data mesh from 2021, 2022, another concept from the past that was a very hot topic. And rightly so, because it allows you to develop data products in a decentralized fashion. Okay? That means you don't have one central data team that produces the data products for all the different domains in your company, but each of the domains, you empower them to produce and to produce their own data products and then give people access to them. Right? This works, this scales, this can even scale across companies, but it needs a lot of rules about permission, about governance in order to work. In the past years, we have seen a lot of customers that have set up something like this, and if you're still in a world where you cannot really centrally govern most of your data, you should really kind of do that homework, because it's also gonna allow you to easily build agents on top of it, or the other way around. If you don't have that, it's gonna get really hard to govern your agents. Because what I'm gonna show next, like this is the baseline for it. And what it is a vision that we call the agent mesh, all right? So what does this mean? The different domains, they don't just build data products, but they also build knowledge assistants on top of it, right? Agents on top of it. Why is this a desirable state? Because data democratization, it doesn't stop with permissions. It doesn't stop with giving people access to the data. Because if I'm a manager and I have access to the supply chain data, it doesn't mean that I can answer my questions, right? It doesn't mean I have the data literacy on this specific data so that I can translate my business question into the right data question. And even if I can, I might still screw up writing the SQL code, right? So this will democratize the data access a lot more than the data mesh concept. Now, governance is really the make or break aspect when you want to implement this. And unfortunately, what we see as kind of the standard out in the wild today is that people or companies that build these solutions in isolation. And that leads to, duplication of efforts, end sources of truth because you copy your data assets, and change management is just, kind of horrible. Here you see an example how that can be a governance problem. So engineering, they build a troubleshooting assistant. Supply chain, they build an inventory expert agent. And customer service, they build a customer service agent, all on their own copy of the product data. Right? This cannot work. Your customer service agent and the troubleshooting assistant from the engineering team, they might produce completely contradicting information on how to solve a problem with one of your products. So the question now is, in the world where you have these multiple domains in your company, all building their own agent, how can they reuse the assets? One version you see here, right? You have a customer service team, they build a customer service chatbot, and they leverage the inventory table from the supply chain team and the product vector search from the engineering team. So this is already better, right? We're not copying our data around, but is this really the final state that we should aim at? Well, let me ask you this. Does the customer service team really have the knowledge of the supply chain data that they need in order to build an agent and evaluate it to make sure that it writes the correct queries against the inventory table? No, they're not, right? They're not the expert on that data. And this is where a new philosophy comes in. And I think it's a wise one, where maybe if you have an agent in one domain and it needs to access data from another domain, it shouldn't access the data layer of that other domain. Maybe it should access the agent layer of that other domain. And this is where we get into this final picture, where you have each of the domains, they build their own knowledge assistant on top of their data products, and then if you need to access them across domains, you interact with the agent layer. And that also allows you to build, your agents in the frameworks of your choice. Right? You see Crew AI from the engineering team, you see customer service team building it in LangGraph. As long as you expose your agents through standardized interfaces, you're going to have that freedom to do that. Of course, given the fact that you are on a platform that allows you to have that freedom of choice with development frameworks, like Databricks, for example. Okay, so to recap, we talked about how we can go quickly from experimenting to prototyping, but then also deploy to production with in-depth traces and monitoring and evaluation, and how we can get from there into a multi-agent world. And I hope this helps you to go from this picture, where you have these huge gaps, to move forward a little closer to this picture again, where you have a smooth transition from experimenting all the way through to the scaling phase. I think we have some time maybe for questions. Thank you very much. In the meantime, feel free to connect with me on LinkedIn.
Yeah. Yes, we still have some time for questions, if you have any.
Hi, thank you very much. You were talking about the LLM as a judge for the judging another output of the other LLM, but when we are talking about agent, how we can do this? Because the agent is still different from the LLM when we are talking. Because what we were seeing, mainly it was the output we received from the LLM, and the agent are doing the actions. So they are different from LLM in reality. So how we can use this meta judge also for the agents?
Yeah, so you're right. So an LLM is not an equivalent, or it's not the same as an agent. So an LLM is always part of an agent solution. It's kind of the central part. But an agent, at least in this case, it's a natural language agent, right? So it still produces a natural language output. And you can use those LLM as a judge to judge all of the intermediate steps, the inputs and outputs. If you have the ground truth label, you can judge more of it. If you don't, you can judge less aspects of it. And then you can also have an evaluation data set for inputs to the agents and outputs to the agent, which is also natural language. So you can also do LLM as a judge on it. It doesn't really matter what creates those generations. It's just necessary what is the form of it, and if it's text, you can use LLM as a judge. Yeah, happy to discuss it further offline also.
Thank you. Thanks for the speech. Short question regarding the shift in philosophy that you mentioned, and sort of not retrieving the data directly from the data stores or the data products, but introducing another agentic layer, so to say. Doesn't this introduce additional, I feel that it introduces additional complexity rather than making things simpler. So can you explain shortly what is the benefit of this? Why we should not go, directly to the data products themselves, but introduce this intermediate knowledge layer, as you called it? What does it help with? It doesn't sound intuitive to me.
So, good question. So you want to build agents, right? Let's just settle on that you want to build. This only matters if you want to build an agent in your company. The idea is that you need to let the experts for the specific data build the products, and then you rely on that instead of building your own and duplicating the effort. Because if I build an agent in one department and I need engineering data, and I need to build an agent in another department that also needs engineering data, I have a duplication of efforts if both of them need to build this tool and evaluate it to make sure that it's retrieving the engineering data correctly.
Okay.
And even, let's say you can manage that duplication of effort, you might not have the expertise in that other team to really judge whether what you're doing is correct. So this is where this idea of letting the experts build the agent layer on top of their data, evaluate it, and then you provide that layer to the other domains.
Thank you.
I have a question.
Yeah.
Because you mentioned judge and expertise, and I want to come back to the initial question, the first question about AI judge. When you say talk about the example of painting, or just thinking I'm not able to judge whether painting is good or not, I might rely on the expertise of painter to tell me, depending on what kind of painter I'm watching. So does this require the AI judge also to have domain expertise to do their jobs?
So you're asking whether the AI judges need domain expertise in order to do their job? I mean, it depends. So the LLMs that we have today, they're quite powerful, right? So for example, it depends what you want to judge, because we have all these different dimensions, right, that I've shown before that kind of make the picture of how well you're doing on a single question. If you have a question and you have a ground truth of how the answer should look like, there are a lot of LLMs today that can compare those two questions and can tell you whether it qualifies as a complete answer that covers all of the facts and doesn't introduce any additional things that are incorrect. The same goes for safety, right? For example, let's say you want to avoid harmful language. You can use something that is out of the box that can already cover a lot of things, but let's say maybe you define harmful language as your company a little bit different. You can also solve this with prompting, right? And this is also how you can introduce domain language. So it's the same really as building any other LLM system. You start with prompting, try to introduce the domain knowledge like this. But then you can still go to fine-tuning later if you have enough data and maybe you want a smaller model that does the same job. But you don't necessarily need the domain knowledge. It comes with the evaluation data set itself.
Okay, thank you.
Thank you. May we ask this question on private side? That would be great, because we are running out of time.
Yeah.
Thank you so much, Javier, for your presentation. It was great.
Thank you very much.